In this video, Thomas is going to show how to desolder a NAND memory module and how to extract the firmware from it.
Yeah, welcome back everybody. Today's target is a DDC, a direct digital controller from Keyback & Pater, a small German company. You see at the end there are a lot of interfaces for the field buses. We open the housing. We will probably find a lot of PCBs connected with each other. Yeah, as you see. There, the big chip seems to be the CPU. Yeah, it's in Motorola. Motorola has been acquired by Freescale, which have been acquired by NXP in the meanwhile. So the Motorola M68000 has been a very popular CPU in the 1990s. There is a debug interface, which we will not use today. It might be hard to connect to that debug interface. We have the usual components on the chip here, on the system on the chip. We would like to go a different way. We try to unsolder a NAND memory chip here. For that we use a hot air pump or a hot air gun. We warm up everything. You cannot do that with a normal soldering iron. So we constantly suck on top of the chip and warm up the contacts. The tin will melt and finally the chip will come up after a while. We have to make sure we don't overheat the chip, so 80-85 degrees is fine. And yeah, we see a very clean chip here. The contacts are all clean, can be used directly in one of those programmers. This is a model used for program and for readout flash memory. We see all the contacts on both sides are being connected. And finally, we are able to use MiniPro, which is the program to interface with that device. Yeah, we have to find out what parameters it takes. We want to read out the memory content. We have to find the right device type. There's a command line switch to get all the supported flash memories. So there's even one to search for the right one. We can see what's printed on top of the flash memory. We use that to search for. So minicom -L, and we enter what we see on the surface. And probably we will find the right one. Yeah, there it is. It's the TE28F160, and it comes in a TSOP 56 pin housing. So we use MiniPro we try to read out the memory content here. We entered the correct device type. And let's see what's happening. Yeah, there's something missing. The programmer itself needs to be loaded with kind of a firmware. So we try to do that. We try to download everything. It's copyrighted by a Chinese company, so that's why it's not coming with MiniPro itself, but there's a download site available, so the customer can download, or the user of this program can download everything he needs or she needs to program the little flash reader. And yeah, finally we are able to read out the entire memory, 0.5 seconds for, let's see, it should be in the range of 2 megabytes. Yeah, there it is, 2 megabytes of memory have been read out in half a second. Very fast for that time. Remember, the device is from the 1990s. So let's have a look for some strings in the dump. Oh yeah, that looks promising, but not very well. You see the byte order seems to be somehow misaligned. So what we have to do is we have to swap the even and the odd bytes. We use Claude to generate a small program. I've copied that program into that shell script here, and we enter two files, one for the input and the other one for the output, and we'll probably align all the memory content in the right way, so swapping every even and odd byte will do. After that we can run strings again to see if there's something useful. And here it is, keybug and pager is clearly readable, and there are a lot of error messages. So after changing the byte order, we can use Ghidra again to import our dump. Make sure we use the right one where the bytes are aligned already. Yeah, and then the usual process starts. We have used last time. We choose the right CPU type here, Motorola 68000, and the right subtype. And yeah, run an analysis in Ghidra as usual. And let's see whether we have some useful output. So we can expect some machine code that in some way makes a bit of sense. This looks very promising. We have branch operations. I'm not very familiar with the Motorola 68000 machine code, but Ghidra is helping us. We can see the function call graph. That looks very useful. And after that, we can start with the usual firmware analysis process. See you in the next video. Bye bye.